No.
How's everyone doing? So my name is Yunong, and I've got Richard here with me, and we're really excited today to be talking to you about the Node.js Postmortem Working Group, and we're here to give you an update. So a little bit about myself. That's great. 1 second. And is it working? Arrow keys don't work.
You're on there now.
All right, we'll have to click, but that's okay. So yeah, I'm Yunong. I work at Netflix. Hopefully some of you have checked out my talk from yesterday, but we use Node quite a bit. And the tooling that we're about to talk about is really quite essential to everything that we're doing at Netflix.
Hi, so I'm Richard Chamberlain. I work at IBM's location in Hursley Park, Hampshire in England. This is my office, a nice stately home there. That's not actually true. My office is around behind the trees on the right. That office is the boss's office. I get to go there occasionally when things are bad. So this talk is about what something called the Node.js Post-Mortem Diagnostic Workgroup, bit of a mouthful. So this is about diagnostics for in production node, where you do, as Yunong will explain to you, you do not get to attach a debugger, and you do not get to be there when the thing goes wrong. So it's about diagnosing problems based on broken bits that you have after the event. So there was about a dozen people there in the working group, but it's an open thing. It's not a secret society. All the deliberations of the working group are on GitHub Node.js/postmortem, and we have intermittent meetings, virtual meetings, and some of the people in the working group have got the time and the resources to actually contribute code, and others are more of kind of advisory. So the mission covers adding support. There was a kind of gap seen in the support for postmortem diagnostics, assisting in development of those extra features we need. And then where there's common ground, like interfaces and dump formats, we're trying to agree on some of those. We've done quite a lot of work this year, but I'll let Yunong describe from the sort of sharp end what his problems are and what he's been using, and then I'll come back on and say what the Postmortem Working Group has been doing this year. Yeah, and we'll see if there's a correlation between those two. So,
Great. Oh, now it works. Sweet. So who here debugs Node.js? Hands up if anyone's ever done any debugging. Do you use any of the tools that we've got on these slides? Right, that's great. So these are sort of the typical tools that one would use when something goes wrong with their Node application, right? It's pretty standard. You attach a debugger. What's all the same about all of this stuff? Like what, is there a common theme that ties all of these debugging tools together? I won't leave you hang. You can only really use them in a test environment, right? And the reason is that, you can't really go and attach a debugger to production, right? Because if you did that, then the process would halt, and whatever customers you have that's currently connected would not receive a response back. So what do we do about production, right? How do we handle failures and bugs in production, and we need to debug them in production? Well, to solve that problem, I thought I used a nice little analogy here. Does anyone know what this is? Come on, got some nerds out there, right? That's right, this is Pluto. I was actually really excited last year when the New Horizons probe flew by Pluto and took some really amazing pictures. And if you really think about it, NASA kind of has the same problem, right? They're sending a probe out into space to take some pictures and collect a lot of information about Pluto, but you only fly by Pluto once. And so let's say you're flying by Pluto and there's a bug in the application that the probe is running on, right? What would they do? Would they attach a debugger and debug the problem? And then it's like, hey, we figured out the problem 3 hours later. Oops, we've flown past Pluto, right? And we only get this one shot to fly past Pluto. So how does NASA really deal with this problem? Well, it turns out they use something called core dumps and postmortem debugging. So even back in 71, they released this paper from the JPL, which is really the team that builds a lot of these probes around taking a core dump when there's a problem with a probe or some process, and then debugging it later, right? And then immediately restarting the spacecraft so they can go back and begin data acquisition again. Because again, you only fly past like Pluto or Jupiter or Saturn once, and you want to make sure that your uptime is always there to capture all the data. And this is kind of very similar to sort of what most of you folks probably have problems with in your production environments, because you have customers you have to serve and you want to do the same thing. But a little bit more about core dumps first. For most of you that didn't know, the term core dump actually comes from magnetic core memory. So way back in the day, back in the days of punch cards, computer memory was actually stored on these magnetic core memories, right? So you see that each of those little dots is 1 bit. And the way that engineers used to debug their programs was to dump out the contents of this core memory. And so they would print that on paper, on spools of paper. And that's how the term core dump was actually initially coined. And with that, dumping out the core, post-mortem debugging was also born. And like we were saying earlier, we have some of these pretty critical production constraints, just like NASA, for at least at Netflix. Uptime is critical, right? If we have a bug in our systems, we want to make sure that you go back and watch all the great content that we have. So we want to make sure that we're always up. A lot of these bugs are not easily reproducible because we have tens or hundreds of thousands of nodes in the system, billions of RPS per day, so we can't really simulate that environment. And again, our primary goal is to resume normal operations as soon as possible. And that generally means then have you restarted the application or the service. And so post-mortem debugging really lets you take this more, I want to say novel, but this technique's been around for a while, for a very long time actually. This really awesome approach, which is like you take a core dump, which snapshots the entire process state of the application, and then you take the top path, which is you immediately then restart the application, right? And then you continue to serve traffic. So whatever bugs you had, you restarted it now, and you should be hopefully back to serving traffic. And then you can go ahead and take this core dump and load it somewhere else. Meanwhile, your stack is continuing to run, and it's healthy, but you can take the core dump, load it somewhere else, and then debug it sort of at your own leisure, take your time, and really engineer a fix and figure out what the problem is. And we think this is really important because it lets you root cause a lot of these problems and prevent them from happening in the future, right? So how do we do this with Node? Actually, this is one of the reasons we use Node on Netflix is because there's this rich set of tooling that's available, and Rich is going to talk a lot more about that later on. But you can actually configure Node to abort an on-call exception here with just that flag. So now if there's an on-call exception within Node, instead of just that stack trace you see there, you see on the bottom actually also dumps a core. So the operating system will actually save a core dump of the process. And what the core dump will really give you, in addition to where, which is the stack trace, which you normally already get anyway, is why. Like what is it on the heap and the stack variable state that actually caused the process to crash? And so in addition to having just no dump core when there's an on-call exception that's been thrown, you can also generate a core dump with a utility called gcore, which is available on most Unix-like systems. And that'll take a core dump of any process while it's running. It'll pause the process very briefly. And we use that all the time in production as well. If we think we have a memory leak or processing a bad state or something, we just want to look at the core. So let me show you how we actually use core dumps with an example, right? Technology. So yesterday I gave a talk about our new sort of Netflix API stack. And so you notice on the second column from the left there, we have a Node API stack. And that connects to our Edge Services API. And the way that the RPC really works is that there is a connection pool. So there's a connection pool within Node, and it maintains a set of connections to a bunch of API instances. And so as we were sort of building out this new stack, we kept seeing this in the logs, which said, hey, there are no more free connections in the connection pool to connect to the downstream services, which is really weird because we would look at the downstream servers and they would be all healthy and they would all have availability. So it was really weird. But then how do we debug this problem, right? Because this only happened in production in some really, really rare cases. We were unable to reproduce this in test, and we in fact had no idea what the state was. Well, this is where post-mortem debugging comes in handy again, because we were able to take a core dump, restart the process, and then go look at the state of that process. And so using one of the debuggers that's available as part of the work that's been done by this working group called MDB, we were to load the core dump and run something called find.js objects, which and pass a parameter called underbar connections, and that's sort of where the connections were being stored in the pool. And here we could see that it actually prints out the JavaScript object, and this is just a blurb, but it shows us that, hey, we had a bunch of all of these free connections, but none of them were showing connected. So now at least we knew like we had free connections. There were no problems there. There's probably some problems in the logic in which we were freeing or freeing the connection list or something like that. And so this really gave us a really critical view into like, hey, how things were working, and it made it really easy for us to at least pinpoint where that problem was coming from. So one thing that I wanted to leave you with is that Postmortem debugging is really critical for us to our large-scale production node deployments. And I think for any of you who run Node at a large scale with a lot of production traffic with customers that are directly impacted, it'll be really helpful for you too. So I really encourage you to take a look at this working group and check out some of the tools that we've been building. But with that, I'll hand this back to Richard, who's going to talk to you about the rest of the working group. You'll have to click because the arrow keys have stopped working. So you just click.
Click on here.
So that slide right there. So.
I'm not getting it.
Oh, just sorry. Click like that.
Okay. So yeah, so I was glad to hear that the core dumps are still useful. There's some legacy skills might come in handy here. So the things we focused on in 2016 in the working group were a Linux and Mac solution for analyzing core dumps. I'll go over that in a minute. A proposal for putting a JavaScript API on top of that capability to give us more ability to develop more usable tools on top of that. A bit about heap dump, and a lightweight dump which we're calling Node Report. So here's some of the main pieces in the picture. So down the bottom there, core dumps. Now a key thing that the Dave Pacheco and the other guys in Joyent did a few years ago was to add something called Postmortem metadata into the V8 runtime. So what this gives us is just a nice set of offsets, constants and types that we can use to pull apart the JavaScript object headers and the JavaScript stack frames. And this is important, otherwise you'd only be able to see a native stack out of a core dump. But with this stuff they put in, you can now get JavaScript information out of a core dump. And they exploited that in their Joyent MDB debugger, and that's been around for a while. The thing they have is what they call MDB V8 plugin, which gives you the extra capability on that debugger to look at JavaScript artifacts inside a core dump. And then more recently, Fedor and Dutney, to whom we raise our hats, did the same, or started the same sort of work for a debugger called LLDB, which is part of the LLVM and Clang open source tool set, which is a nice open source project to be working with. And that gives us support on Mac and Linux. And it's got some cross-platform capability, so you can read a Linux core dump on your Mac. So I'll tell you a bit more about what we did there. Top right, heap dump. Now there's issues with heap dump, and Yunong probably wouldn't use it in production, but it shows the way in which you can get a nice postmortem tool, because the heap dump, which is a JSON format thing generated by an API in V8, is readable by the Chrome developer tools, and that straight away gives you a nice picture of the heap with the dominated tree analysis, and you can more or less look at that and straight away see what your problem is if you've got a memory leak or you're running out of memory. So that's kind of pointed to the sort of nice tooling end-to-end story we want with core dumps, but we don't have that yet. On the left-hand side, something I'm not going to talk about so much is what you can do with a live application in terms of tracing, logging, and profiling. Because there's another working group, which was called the tracing working group, now called the diagnostic working group, and they're doing some good stuff, Ali Sheikh in particular, on adding low overhead tracing capability into V8, and hopefully we'll be able to use some of that in a production deployment. So going on about core dumps, as Yunong said, we've got the capability to create core dumps when we want them, using gcore or by the automatic triggers brought on exception. And with these extra capability of these plugins using the metadata, we can now look at JavaScript stacks, heap objects, and source codes in a core dump after the fact. So to catch up with what they had on MDB, a guy I work with called Howard Hellier has done a lot of work actually landing changes into LLDB itself, and LLDB 3.9 has got an enhancement which lets us get to all the memory regions that the heap are in, and that's a big step forward in terms of getting JavaScript objects out of the core dump. We've also filled in some of the gaps in the set of commands you have available on that debugger, and Fedor's recently put a performance improvement in, which has made a big difference in terms of looking at large heaps. So we've made some good progress on core dumps. So just to show you the commands you've got available with the LLDB debugger and the others. First column is the Joyent MDB debugger commands. Second column, the LLDB commands, which is LLNode plugin. And the third column, an earlier tool that IBM have for their platforms called IDDE. So the key ones there, you've got JS stack to print the stack trace. That's usually, at least on the LLNode one, it's a mixed stack trace, shows you the native frames and the JavaScript frames when the core dump was taken. The find JS objects and find JS instances commands let you either list all the objects in the heap or go and hunt for particular objects you're interested in, like Yunong did, or objects by property name. and JSPrint to print those objects. And then further on down, there are more commands than listed here, but further on down, there's the find references were important when you're looking for memory leaks to find out what's keeping an object alive. So you've got ways in which you can navigate around the core dump using those. So a good set of commands now on both those two debuggers, which covers the platforms we need. Just a quick example. So this is a JSPrint command on LDB showing a native module object. You can see it's pulled out the properties, the file name ID, exports, load and loading. So we've got a couple of strings there, a couple of booleans. And one of the properties is the exports property is actually a function. So we can drill down into that, run JSPrint -s on that address. And you've got the source code for that function and other information about that function. So we've got lots of capability now for looking at those core dumps, but this still isn't particularly usable. This is still nasty line mode using those tools. I'm just going to switch now quickly to Heap dump, because as I say, that shows us the way in which we have a nice tooling story. And there's a very popular NPN written by Ben Nordhaus, and it's a very commonly used tool. Gives you a snapshot of the heap in JSON format. The problems with it are that because the snapshot API is doing a lot of work, it's indexing objects and it's separating objects out from the references between objects. It actually is a big hitch when you run this thing, and it also consumes a lot of memory as it's producing the heap dump. So in a production system, especially when you're running out of memory, that's not an option. So I don't think Yunong would use it. But like I say, it does show how you've got a nice format, which then leads you into a nice GUI tool, which will take you straight to the problem. So what's coming up, hopefully, next year with, on top of those, the LL Node library, we can build a JavaScript API, which will give us a nice way of producing some more usable tooling on top of that solution. So the API would have things like getThread, getFrame, getObject calls in it. And a contribution from Dave Clements in Nearform was to say, can we output JSON representation of objects in a core dump? So kind of resurrecting the objects, if you like, they can then go into other tools or other viewers. So look out for that. So the way that would build on top of what we currently got now, the green box is what we have, the solution we have now, the LLDB command line debugger, with that plugin being able to read JavaScript information from a core dump on those platforms. So on top of that, a JavaScript API, and then web or GUI tools using that API. So I've got a quick example here of what that might look like, a simple example running on Node using that API. So we've loaded the core dump because into this application, and we've got a couple of options to display the threads and the heap. So here we've just done a listing of the objects of the heap by total size taken up, and you can see this is obviously a rogue application with 800,000 of those my record objects. So that's the point at which you would investigate. But with that API, you could then develop tools like this, where you'd be able to drill down on some of those objects, maybe graph things in a more interesting way. So we've got some hopes for that coming up. Oops. How are we doing? There you go. Just to cover one or two other discussion topics like they've been going on in the community, improving that metadata I talked about, some code sharing between the different tools. We've had quite a lot of discussions about the heap dump format. There's some other interesting topics about catching or not catching exceptions, whether to continue or abort. Some good discussions on GitHub on those topics. We've been moving these projects to the Node Foundation, which is a better place to have them than scattered around. And lastly, this lightweight report, we're calling Node report, which we've been working on. I'll just show you a quick couple of slides on that. So this is now available as an NPN. So it's the idea is that core dumps, whatever you do, are still going to be big, ugly things. It'd be nice to have a simpler solution for at least some basic problems or for early triage of problems. So this is an NPN written as native NPN so that you can get this thing out when JavaScript has stopped running, so in out-of-memory situations and so on. We've got it triggered by exception, fatal error in Node, triggered by an external signal sent in, the kill signal, and a JavaScript API for it. And just to show you what the sort of things it contains, I've got one here which I've trimmed it out, but at the top there's a section that says what the event was that generated this little dump. In this case, a signal sent in, sig user 2. Below that, the JavaScript stack trace. Below that, the native stack trace. And then some stats about the current heap sections, how full they are, how big they are, some resource usage information, and we've got more information about the parameters used in that program, the environment variables, unit settings, that kind of stuff. We still need to add some more event loop type information into there for that to be useful, and outstanding callbacks, that kind of thing. But hopefully that'll be useful in production to produce a simple report that you could look at straight away without any tooling at all. Onwards. So, summary up. Yunong did the challenges, and say mainly what we've been doing these years is improvement in the core dump analysis to give that solution on Linux and Mac. And the working group has been functioning well as a focal point. Lots of things discussed. We could do with a few more participants, so there's a bit of a call to arms here. If anyone's interested in helping out, have a look at what's on there, Node.js/postmortem, and it's all in the open. And there are, say, 2 projects on there that you could have a look at contributing to. And yeah, do have a play with some of this stuff and let us know what things work and what things don't work. I'd be very interested to hear how people are getting on with that tooling, especially the newer core dump tooling using LLDB. That's it. Any questions for Yunong or myself?
Alrighty, thank you very much.
Thank you.